AI minds, quantum leaps. Cut the noise, dive deep. Truth unlocked. Dr. Mike on the mic. Tech Unfiltered is on the clock. Now it's time for the show.
Here is the first real AI rationing system, and it doesn't ration tokens. It rations megawatts. Welcome to Tech Unfiltered. I'm Dr. Mike. Today we're talking about the least glamorous and possibly most important part of artificial intelligence, the power grid. PJM interconnection runs the largest electrical grid in the United States. Its territory covers parts or all of 13 states and the District of Columbia, from Virginia West to Illinois, serving about 67 million people. On July 28th, TechCrunch reported that PJM is preparing to curtail data centers and other very large customers when the power system is under stress. Curtail simply means asking a major customer to reduce its electricity use for a period of time. Let's be precise. Nobody is scheduling blackouts for your home. Nobody has said a neighborhood will go dark so a data center can keep running. The story is that AI scale demand has become large enough that the grid is developing rules about which customers can reduce usage first when supply gets tight. The policy described in the report would begin with the delivery year, starting in June 2027. It would apply to data centers and other large loads of at least 50 megawatts. Those customers would be compensated for reducing demand, much as factories and other industrial customers have been paid for decades through demand response programs. Notice can range from minutes to days, depending on the program and the forecast. This is a reliability contract, not a punishment. 50 megawatts is industrial scale, comparable to the average use of tens of thousands of homes. That comparison varies by location, season, and whether we mean power at one moment or energy over a year. The useful point is scale. One computing campus can arrive on the grid like a small city. Why now? PJM's July capacity auction offers a clear answer. A capacity auction pays power suppliers to be available on the days when demand is highest. For the 2028 to 2029 delivery year, the auction procured about 138,000 megawatts of generation and demand response, including certain self-supplied areas, brought the total to about 149,000 megawatts. It was still 6,831 megawatts short of PJM's reliability requirement. The price reached the federally approved cap of $325 per megawatt day. PJM placed the headline value of the cleared supply at $16.4 billion, while warning that this is not the same as the amount customers will ultimately pay because some electricity is hedged or self-supplied. A shortfall does not mean the grid will fail. PJM said that directly. It means the region would operate with slimmer reserves and greater risk. The operator reported a reserve margin of 14.7% and plans a separate procurement to add near-term supply. The responsible conclusion is simple. The cushion is getting thinner while the price has already reached its cap. That distinction matters because grid planning is about probabilities, not a prediction of one certain blackout. Operators carry reserves so they can handle a heat wave, a plant failure, or another surprise without interrupting service. When the reserve target is missed, the system has fewer comfortable options. It may need more demand response, emergency generation, electricity imports, or conservation appeals. Curtailing a pre-identified industrial customer is one controlled option in that toolbox. It can protect the wider system while engineers work on the slower solution, adding durable supply and transmission. We saw a preview during the July heat wave. On July 2nd, PJM's instantaneous load reached roughly 162,700 megawatts after demand response reductions. Some generation went offline. The operator activated about 6,000 megawatts of emergency demand response and warned utilities to prepare for the possibility of moving data centers and other large loads to backup generation. That final step wasn't needed, and customer service wasn't affected. The system held. But the warning shows that asking large computing facilities to rely temporarily on their own power is no longer an abstract proposal. Is this all AI's fault? No. Power plants are retiring. New generation can wait years in connection queues. Gas turbines and transmission lines have long lead times. Broader electrification, industrial growth, and extreme weather also matter. Data center growth is a major new driver arriving faster than supply can respond. But it isn't the only cause. TechCrunch cited a Bloomberg Energy Research forecast that American data center electricity use could quadruple by 2035 and reach roughly 1/5 of US generation. Within PJM, the forecast suggested data centers could consume about 34% of electricity. Those are projections, not guarantees. Their rapid upward revision shows both urgency and uncertainty. Why should this matter to you? Start with reliability. A large, flexible customer can be a safety valve. A data center might use batteries, on-site power, or delay non-urgent computing so the grid can protect customers with little flexibility, including homes and hospitals. But data centers also support communications, finance, healthcare, and other essential services. The rules need clear priorities and tested plans. Then there is your bill. Capacity costs can flow into retail rates, although the timing and amount vary by state, utility, regulation, and contract. The public question is whether households should finance new generation and transmission built mainly for enormous new loads, or whether developers should carry more of the added cost. There is also pollution. Many facilities use diesel backup generators because the fuel is easy to store. If several campuses switch to diesel during hot, stagnant weather, reliability may come with a local air quality cost. Not every data center uses diesel. Some rely on batteries, natural gas, fuel cells, contracted power, or direct reductions in computing. Whatever the method, emissions and performance should be measured. This is also a local fairness issue. A data center may create construction jobs and tax revenue, while its power demand, substations, transmission upgrades, noise, and backup emissions are concentrated in a particular community. Those benefits and burdens rarely arrive on the same schedule. Clear public reporting helps residents see whether promised jobs, grid investments, and environmental protections actually match the scale of the project. Finally, consider incentives. If the grid promises unlimited electricity at shared rates, developers have less reason to build where power is abundant or to bring new generation. PJM is developing a connect and manage approach. Large customers may connect, but they agree to operate flexibly when the system needs relief. The key is making sure flexibility promised in a contract actually appears on the hardest day of the year. Here is my inference. This could become a practical template for AI infrastructure. Instead of asking the public to absorb every higher cost or asking the AI industry to stop growing, regulators can require the newest, largest, and most flexible loads to carry more of the cost and reliability responsibility they create. Some of the most important AI policy will look very ordinary. Utility rate cases, connection queues, zoning, backup generator permits, and rules for assigning grid upgrade costs. Those decisions may determine where AI grows and who pays for it more directly than arguments about distant superintelligence. If you live in a PJM state, watch your state utility commission. Ask whether new large loads must bring new power, accept curtailment, pay for upgrades, disclose backup emissions, and verify their demand forecasts. For everyone else, remember that every digital answer has a physical supply chain. AI may feel weightless on a phone, but it runs on chips, cooling systems, transmission lines, generators, land, and contracts. AI is becoming infrastructure. That means the rules are utility rules. Who connects, who pays, who cuts back first, and what happens when the weather turns. If data centers want city-sized electricity, they may need city-sized responsibilities. I'm Dr. Mike. I'll see you in the next one.